So question being, will everybody have equal access to urban air mobility? What about this, what about the Parisian banlieue, for example, if we speak about the manned urban air mobility? Is it going to lead to yet more segregation than we already have? So some of the hottest real estate markets right now are the air rights. If we look at New York City, for instance, or a city like Mumbai, this is all about also who is colonizing the air. Is it the urban air mobility that is colonizing the air? Is it kind of more and other tall buildings? So what do we actually have to expect with regards to urban air mobility when it comes to who has the right to the air? In urban environments, but maybe also in environments outside of the city. Which kind of brings me to a question for maybe Jaron first. You showed some of the visionary ideas of Moshe Safdie going way back, and so I was wondering in how far maybe those models of design, if you think of Broadacre City dating back to the 1930s, for example, but also then other examples of very visionary ideas that were developed for vertical takeoff and landing aircraft in the immediate post-war years, for instance, so kind of very expansive and beautiful, in part even landscape designs that were developed at that point in time. Can these be models yet again? Would that be something that you as an architect today would look back to also? And how far should we be doing that? Because of course those kind of design utopias were actually never realized. So for Lorenzo, I was wondering, so Lufthansa's head of flight safety research, whom you probably know, I'm guessing, and probably many in the room here, has recently said that the public hype about autonomous flying and autonomous vehicles more generally is a marketing gag. And then also aviation analyst Richard Aboulafia has been quoted in the Washington Post as saying about urban air mobility that it's quite possible that unicorns could achieve air mobility. You can never rule out anything, but I'd give the unicorns a better shot. So of course, I think you kind of very nicely proved to us that there's so many things to take care of before this is actually ever gonna happen. And you talked about, right now the standard in civil aviation is that, or it's premised on one bad accident every 2 million flights. Is that correct? All right. And so it seems that that would basically mean that we would have to live with 1 in 100 million autonomous flights losing digital connection. And if we could live with that, right? So basically, I would be very curious to hear kind of more about your thinking or thoughts, how kind of feasible this all actually is. And then Olivier, I noticed you had the maps showing us San Francisco and some other cities, Sao Paulo, that are actually currently already working with flight taxis. New York City has a flight taxi connection from Manhattan to JFK. But I noticed that the routes that you had were actually above water. And so I'm also wondering, what is that kind of environmental, or is there something that kind of made you choose that route? And if so, what is it? So what are the environmental implications of this routing that happens? Yeah. So if anybody wants to start.
Remember your question?
So the question is about what it means social. Mm-hmm. In fact, this is what I tried to bring up front. The main argument of my discussion is that we look at what we call public acceptance, that for me is not the right term, only as a consequence. First of all, I think here we're talking about urban mobility, urban life. So it is not just about another technology. The terms of technology acceptance and adoption are coming purely from technology innovation. And they're coming always after. And we have a lot of examples. Even look at Uber, the scooters, the different examples of technologies coming, and then being rejected or having problems to adjust to the reality, what a city or the citizens may want. And I don't think that with air mobility we can afford that. We cannot start like with scooters to fly and then see maybe we don't like it that much for different reasons. So we have to be a bit more proactive and responsible at the beginning. And this is where I believe we need to involve the society to be a co-designer. To do, we're talking a lot about design thinking, putting the user. I think here is about doing design thinking with the society. And this means that we may end up with solutions that we do not imagine or we don't like as an engineer, because the actual business case might not be what we would like to be to justify what we do. But the point here is not what the technology can do. Artificial intelligence, machine learning, the digitalized airspace will allow that many of these vehicles can fly without colliding. The point is what we want the technology to do for us. And this is a big difference. And this is where we have to take our responsibility even as citizens. So you ask the question, who is going to use this? If we talk about democratizing this, it means that everybody should have access to it in the same way we have access to a bus. If we accept that, at the same time we accept that the skies most likely will be congested. And perhaps we start, this is dystopian, but they will be quite gray and we cannot see the sun anymore. But this is what we have accepted because everybody will want to have access. Mm-hmm. So this is a trade-off. And perhaps this is what we as a society, we will accept. Perhaps there will be a benefit from that. Because if we agree as a society that we want only to fly if it is about to move, we can have the opportunity to recover all the ground, to be green and do other things. This is an agreement we have to make, a new social contract. On the other hand, if we say no, it will be only for selected people, who will be these selected? Will be privileged? Then we're going to have a social unrest. Look what is happening in France with the yellow jackets. This is just an example. So perhaps the reality will be somewhere between, or what I mentioned, urban air mobility, UAM for a purpose. We may agree as a society we can use for specific reasons, and everybody can be happy. And this is where I'm talking about embracement. It's not about accepting. Acceptance has a negative connotation. It's about seeing the benefit and want to use it, even if something goes wrong. We use the cars despite the accidents, because we have some benefits from them. But we have to avoid all the mistakes we have done with cars in the cities. All this congestion, we should learn from this. The cities try today to take cars out of the city centers. Will they allow drones to come in?
Mm-hmm. Thank you.
Route selection. So, I have to confess to you that what I showed earlier, it's essentially the current, most of the urban air mobility routes and networks that have been proposed around the world are kind of duplicating routes that are already served by highways, cars, subway, and so forth. And the idea is that, well, if you can fly, then you have the speed advantage, you avoid congestion and so forth. And there's the premium for cost saved. So I think on the social acceptance, I think if that is the way we're thinking about it, clearly a very small a part of the population will be able to afford this kind of service. And that's what's happening in Sao Paulo, quite frankly. So maybe we need to think about it completely differently. Maybe the best applications for urban air mobility are from unusual locations where there's not a large population, but where the topology of the city especially if you have bodies of water, bridges. I try to show this on the San Francisco example, where if you had to take a land route, whether it's car, bus, it's going to take you half an hour, an hour and a half, even in the best conditions. But if you could fly, it's a 5-minute flight. And so here in Boston, some of you might be familiar with a community like Hull, right? This Hull is on one of these islands. It has a land connection, but if we were to drive right now from here to Hull, which is a nice place right on the water, it's probably an hour and a half drive, right? Even on the best conditions. If we could fly right across Boston Harbor, that's a 5-minute flight. But there's not a lot of people. Anybody living in Hull here in the audience? I'm curious. Okay, nobody. But to me, that could be a very interesting route for urban air mobility. There's not a huge market, but I think people in Hull would be very excited about urban air mobility. And they would be willing to pay for that service. But it's not a competition to the public transport. That was your point. So maybe it's more like, when the internet connection, high-speed internet, there's this question on fiber optics, for example. Fiber optics will be put in when there's enough customers, and then there's the more rural you go, the more expensive fiber optics becomes per person. And then you say, well, you better go for a satellite connection or just go wireless. So maybe that's where urban air mobility really has a value, is in the peripheral areas where the topology of the city makes it worthwhile. And if we go for that kind of urban air mobility, I think a lot of the regulatory issues around noise pollution, that if there is a problem or there has to be an emergency landing, you're not actually endangering a lot of the people on the ground. Mm-hmm. So maybe we need to think about it really differently than we have.
Mm-hmm. Thank you.
I wanted to go next on this because I think it's a good silver plate for me to answer on the feasibility, and it's actually also a silver plate to answer why am I here, right? What is a Swiss regulator doing in Boston? And the point is that it's trying to understand these challenges, because it is all about, like, feasibility is about what you want to do, right? Things might be feasible or unfeasible depending on what is actually that you're trying to do. Now, aviation being generally a very conservative environment, even the most tremendous advancements of technology or whatever have always been somehow contained to one of the different silos of aviation, right? So you kind of like, I don't know, you have aircrafts flying with cables and pulleys, and then Airbus comes and say, oh, I invent fly-by-wire, right? Is this feasible or not? Well, at the time it was, whoa, really, I lose my cable and pulleys? Pilots are like, I would never fly this. What happens if the computer fails? Well, could go very wrong, right? But in general, many people now fly with aircraft that do not have any cable and pulleys. But it's still on the aircraft. It's just the aircraft. The challenge with urban air mobility is that the impact is kind of disruptive. It has the potential, depending on the societal choices, to basically blow the entire aviation apart. It just changes it completely. You go from 20,000 flights over Europe to 20,000 flights over a city. Right, so it is basically taking what it exists, throws it away, and completely replacing it from the ground up. And so acceptability there really depends on, like, okay, do we accept that, yes or no, as a society, and how do we going to deal with this? How do we accept for regulators to regulate? So in terms of accident, you made a good point. If I have 1,000 aircrafts flying over a city again, with those reliability numbers that we discussed, you're going to see many crashes, right? For cars, it's normal. We accept that. Society accepts that. For aircraft, it's completely unacceptable. At the moment, every single crash of an airplane is investigated. So you have to change that. I think it is feasible. Whatever choice we make, it is feasible if we, as a society, accept the consequences of this disruption. So I don't think it's feasible if we collectively say, we want to keep the aviation system as it is, we want to keep everything exactly as it is, and simply integrate and superimpose this new toy, which is UAM. This ain't going to work. These aircraft are going to end up costing $10, $100 million, and you're not going to make your numbers. It's just not possible. You're not going to make a flight for $100. Doesn't happen. It's not possible. So you need to change this paradigm completely, allow us to make regulation to that extent, and then actually, yeah, it is feasible. One thing that I wanted to add before leaving to you is this notion of what you mentioned about the routes over the water and all that. Don't forget that today there are cargo operations occurring in the city, right? And cargo operations are there to complement ground cargo delivery mission. So it's very similar to this extent. And in fact, in Switzerland, where we have approved many cargo operations, already over cities, we see exactly those type of routes being favored over every other route. So I think looking at cargo, we will learn a lot about how do we actually kind of map these routes, where is the business cases. That's a very good point, and we can already start doing this now.
Mm-hmm. Thank you.
So, I'll start by saying thank you again for inviting me. This is like the coolest conversation I've had this in a while. And the other thing is I keep thinking about the movie Back to the Future 2, where they don't, where Doc says, where we're going, we don't need no roads or something. So again, that's the extent of my authority on this topic.
Right.
But to your question, or to state something that might be useful for our conversation, I think one of the things we think a lot about is how and if designers can make an impact, a meaningful impact at the city scale alone. And frequently in design competitions or in the kind of practice medium, the practice that we call architecture and urban design, we come across strong limitations. Habitat, as interesting an idea as it was embraced with a limited capacity. We're still talking about the potential of prefabricated housing and rethinking these types of living experiences as you would compare it to the types of urban conditions you live in now, small apartment living in glass towers. And I think where we work a lot and where we look a lot to precedent, again, is Singapore, like the projects I shared tonight. And I think, and even there's a lot of work. In fact, I know that Airbus and other people are doing pilot programs there for drones, moving things back and forth. I know the ETH is there testing things. And I think the reason why they're so successful there is they have this urban authority. It's not just the urban designers and the architects who are at the helm of some of these acronym organizations, the URA, the LTA, the BCA, the STB, all these groups. But it's that when you set out these objectives and these incentives and these rules in the framework that they have there, that it doesn't take an idea like Habitat to do something that changes a city. It's more like you can set out these rules at a kind of grand scale, and then the entire profession of designers and thinkers are enacting these pieces, and it's in that way of working that you can have radical change and really wonderful things that happen. And so to that end, I wonder whether there are ways to connect design thinkers in the kind of urban sector and the architectural sector to the people that are in this room and the policymakers and the technologists and and others, aviation experts, towards some similar models of working together. Mm-hmm.
Thank you. Well, it seems like there is a need for that, as we heard in the last presentation by Vasily, with regards to urban planning, at least, to get the urban planners interested in this topic of air mobility. I would like to open the floor, so if there are questions from the audience to our speakers, or comments.
Thank you. Hello, my name is David Rothblatt. I work for Embraer. And one of the things that I think is interesting, particularly from an architectural perspective, and then when we think about aerospace design and airspace management, is how can we repurpose existing infrastructure to support additional capacity for the urban air mobility industry? And then how could we, and perhaps how we could learn from your firm, how to take advantage of what infrastructure currently exists, whether it's hotel rooftops, parking garages, or just repurposing existing helipads that may exist so that it can conform to what this industry needs. So it may be interesting to have a proactive proposal towards industry. A lot of people are thinking about it like in forums such as this, where we'd love ideas and we're interested in sharing them. But have you, or has your firm had an opportunity to look at the repurposing of existing infrastructure for perhaps an industry that wasn't foreseen when that building or that structure was built, but you found a way to make it work for something that was needed at that time?
Sure. I mean, we're currently faced with this a lot when we talk about what's next in automated vehicles and how that's going to transform our parking garages that are set out in every single building we've ever designed. And we're being asked, like, what are you going to do with that extra space that is no longer needed because you don't need to leave your cars there, cars will come and go. It's just at the beginning of a conversation like that. But I think that many firms are probably going to be facing the same thing, especially firms that may work in transportation sectors like airports. And it's not difficult. I mean, I'll call you tomorrow, we can work on something. But it's about linking up and finding out what are your objectives and your criteria, and then we work together. That's what we do as architects to try to make that work. Another kind of thing I'm thinking about is we're expanding Marina Bay Sands. We're adding another tower. It's not bridging across, but although it's
but it has a pool, right?
It will have an infinity pool. More spectacular is the request, and they've actually in the brief included some kind of a drone port type station for us to design into the. We haven't started yet, so we've get this in the brief, which is kind of cool, and that's happening. I'm sure that might be happening across other architects' doors too.
If I can add, I want to give a shout out to one of the audience members in the back. Parker, would you raise your hand, please? Parker Vasic is a doctoral student at MIT, and he had in his master's thesis, he looked at the LA basin. So what would urban air mobility look like in the LA basin? And if you only use existing helipads, it's a very bleak. You know, they're very sparse. Many of them are not actually accessible, like, you know, hospital helipads and so forth. So Parker looked at gas stations, right? What if we turn every existing gas station, which we know where they are, and on top of the gas station, you know, you have urban air mobility, and it does help a lot, but even that is not a panacea. So density of infrastructure is a crucial parameter.
Hi, Rod Randall from Cirrus Capital. One of the things that you mentioned that would impede the acceptance is the noise of these devices. And many of the new distributed electric propulsion vehicles, still, while quieter than helicopters, are still very noisy. So if you've actually heard the E-Hang machine or the Volocopter or many of these multi-rotor devices, when you look at the blade tip speeds that get very high to be able to create the lift, it actually gets close to the speed of sound and therefore creates more of a noise problem. How low does the noise need to get to in order to get acceptance, and also what level of safety does it need to have so it would avoid the accident like happened at the Pan Am Tower in New York back in the 70s?
Yeah, that's right. But what's actually interesting about the Pan Am accident is that it's the platform that failed and not the helicopter, right? That's an interesting twist on that story. So 70 dB, something like that, 70, 75 dB. What is 75 dB? It's, you know, the hum of your dishwasher. You know, it's sort of on the level of appliances in your house that if they're on, they're annoying you. Mm-hmm. You know, if you're above that, it's not a very good thing. I think Vienna was recently, Vienna is always one of the Vienna in Austria is one of the highest rated cities for livability, and it's also one of the quietest cities. So, if you're thinking about urban air mobility in Vienna, and you're now raising the noise floor across the city substantially over what it's way below 70 dB, I think, the average noise level in Vienna. So it is a crucial point. The difficulty with the small drones, like you pointed out, is if you go for multi-rotor, because the lift you need to produce no matter what. So you go for smaller rotors, more of them, the blade loading and the speed, the noise is of a different nature as a classical helicopter. It's more of a, this kind of high-pitched noise.
Yes,
and we know from experiments with humans that it's not just the dB level of noise, but it's what the frequency spectrum is. And there's certain noise spectra that are much more annoying to us as humans than others. So that's a whole nother, the other thing is if you do have noise in cities with urban canyons, how will the echoes, right? How will the noise then be either absorbed by vegetation or be reflected from other buildings? We actually know very little about this. There's a lot of research to be done. And it is really a key thing. And that's why I think a part of the urban air mobility community is now shifting back and saying, well, maybe these heavily relying on these rotors is not the answer. Maybe we need more fixed wing with very short takeoff. And then once you're airborne, you need less power. And then you're gliding with a little bit of assist. And fixed wing aircraft, of course, are much more quiet.
Right.
So now we have this sub-communities within UAM that are pushing different ideas to deal with the noise. I don't know if you want to add to that.
But then we start to think, what should be the range?
Sure.
Because if you want to do hop, the wing configuration is not always optimal. You need more to hover. And we have seen some recent studies, I think from the University of Michigan, funded by Ford, that show that in order to be, the air mobility in fact can be better in terms of CO2, but it has to be more than 60 miles, if I remember well, fully loaded. So what you have shown from your simulation is more about 40 kilometers. So there are some differences there we have to see. Of course, if it is congested, the story is different, but there are all these details that make the difference.
See, Vasilis works for Airbus helicopter division, so he likes hover.
We have two more questions in the third row. Actually, three more questions, I think.
Hi, good evening. Thank you for the opportunity to be in this smart group of individuals over here and for the knowledge share. My name is Anthony Barrow. I am with a company called E2 Sol, and we're actually innovating new technologies in the renewable energy space. And when I think about air drones, it has a common denominator and that associates with what we're doing, which is power. Okay, so when you look at power, what is going to be the common denominator? Is it going to be digital? Is it going to be electric? Is it going to be some other form? And so as we think about air mobility, we also need to be cognizant of the supply chain to be able to provide in scale what these devices are going to be able to operate on. That's an area that I'm specifically focused on. So I'd like to get your feedback on that.
This is a very good question. It's one of the questions we try to discuss with our cities as part of the mobility demonstrators. We need to have this systemic approach, including the energy. Today, one of the reasons why we talk about urban air mobility is because of the electric propulsion. Because we think it's CO2 zero, but is it? The question is where this energy is coming from. So I think one of the ways for the urban air mobility to be accepted or embraced, it's about to address what you mentioned about the logistics, the supply chain. So I think the energy needs to be also clean, not coming, for example, from nuclear. And the energy required, however, for each of these vehicles is huge. Just think that if you want to have one of these vehicles that is for four passengers, is about a big building, almost like a big shopping center. And we want to do this thousands of times to recharge. So where this energy is going to come, and perhaps it could be more than energy. Then it could be about heat emission. So this is quite a complex topic. That's why we need to thoroughly and responsibly try to address it. We should not do things and then leave the consequence.
Hello, thank you very much for your time speaking to us today. My name is Jesse and I'm a senior at Boston College studying history. What fascinates me is looking at this form of transportation, and it reminds me of looking at the 1950s with the creation of highways and automobiles, something that wasn't seen in America before. What do you believe will be the future of desirable housing with this alternate form of transportation, assuming it could become more mainstream? And if we can look at highways as a physical transportation form, what does that look like in an airspace form, maybe airspace highways, and its impact on housing?
I might without maybe going full future, I might give you a simple example. I was speaking a couple of maybe weeks ago with one of the seniors at Wing. We represent the Wing, the Google or Alphabet company that has now received the first air car. And they've been operating in Australia now since a while, doing testing. And so they do the delivery basically as a service regularly. And they told me, like, if there was a particular house whose owner was really a fan of Wing, right? And he was continuing ordering stuff like every 2 hours. This is my coffee in the morning, this is the thing. And the aircraft was being dispatched there always with the same route. Now, after a while, they started to receive telephone calls from all the other people in the route saying, why is this Wing aircraft always over my house? And it's because that guy is ordering the coffee and then the thing, whatever. And they said, well, okay, this is actually a problem because these people are not ordering anything, but our aircraft is continuously flying over their houses. So what they did is they algorithmically started to change the route, even if the drone is going from same point A to point B, just to avoid this problem. Now, this is actually, from a safety point of view, becoming an issue because then you can forget about the corridor. It's not a corridor anymore because this is an algorithmically decided route on the basis of considerations that you don't even know actually what they are. So this is something that they start to consider proprietary. So I have noise issues for which I need to do this, and what else, right? And so even with a simple test, with a small drone, this problem that you're raising already emerged like straight away, bang on. So imagine when you bring this at scale, I mean, I don't know what the future will be, but it will definitely be something to consider.
Yeah, that's a very interesting question. I think it's a good one. The thing that was brought up earlier also is that with the ability to kind of leapfrog over traffic and all kinds of other nuisances, you could imagine that things become much closer, things that like other cities and other places that you had to go over a river or over a lake or something to get to. So your question about desirability of new places actually comes back to how you set up your network of landing points. So for instance, if you make a decision like finding the gas stations, for instance, that you could repurpose, or using the roofs of like Walmarts or something, because there's like huge surfaces, I was just thinking. That then defines certain routes that then could create these like micro interests. And so I think it's all interrelated. I think that question about how you set up your series of networks could shape new connections where you previously, it's the same thing with Hyperloop. I mean, if you think about being able to go from here to LA so quickly, then you go to LA once a day or something rather than once a month for work or something like that. So I think it's a really fascinating idea.
Hello, my name is Hiroma and I'm currently a sophomore at Harvard studying mechanical engineering. So I'm not so sure if I'm good at numbers or reading, yeah.
I'm sure you're great at numbers.
Thank you. Yeah, I was actually wondering if urban air mobility should be something that a single like public entity like the government should take control of, or if like multiple like private companies like Uber or like the companies that like make the aircraft itself should be in charge of that.
That's a very good question, and in fact is today's debate. We have companies, private, that they want to have control. And cities, I think they're coming a bit late, but they start to see that they cannot be an observer. We have a typical example here in US, I think it's in the state of California, with the scooters. The actual problem of data management of mobility has been really phenomenal. So the Department of Transport has decided that all the mobility solutions have to report the data to a common platform of data managed by the city. Of course, the companies don't like this, because all these digital companies, where do they rely their competitive advantage? On the data insights. So they resist to that. But this is what the state decided there. There are other cities that don't want that. So today there is a type of debate, what is the role of the cities in all of that? There is a sort of, not agreement, but convergence that the cities at least, they set the vision about what has to happen in their city, handle data, manage data, and have a say or even manage part of the regulatory framework. And this goes the question about today's the regulators, the airspace regulators, that they manage the sky, that they have a say on the airspace of a city. And this is in fact where the city say to FAA or to EASA, I'm sorry, dear EASA or FAA, this is my space. This is where we go on the public space going 3D. And the cities claim this space, many of them at least. So they want to have a say about how they are going to manage their own, the city 3D space. And that's why they have now, they become an important stakeholder in the regulatory discussion. So there is no answer to your question yet. This is an ongoing process, and we have to see how it will evolve.
Hi, my name is Javier Segovia. I'm a tech entrepreneur. I'm curious your take on what model do you envision for the future air mobility networks? Will it be more like public transport, like a bus network or a subway network, or should we envision something more like an Uber or Lyft network with a lot of, or privately owned cars with most rides being one person? So are we, and what steps are we taking to try to ensure it's more like the former rather than the latter, so that there's obviously efficiencies from a, carbon footprint, et cetera?
So for it to be more like an Uber or Lyft service, it has to be profitable. And so based on some of the numbers that I showed you, let me get back to the San Francisco example. You know that route in San Francisco? So that's an 8-minute flight, but then you have to account for the moving in and out. If it's all electric, at this point, you would have to swap the battery pack because you can't recharge it. So let's say you can change out in 5 minutes. New passengers come in. So that San Francisco to Pier 39 route, you could fly it 3 to 4 times per hour in the best case, right? So that's a revenue of about $420 revenue per vehicle. And you saw that some of those vehicles, flight hour, operating cost per flight hour was $500-600. That's a losing proposition. Some of the concepts would be profitable, but maybe not by a lot. So I think for certain routes, the commercial operators of UAM, which I think are emerging and will be successful in some cities but not others, are going to cherry pick. They will learn adaptively which routes are popular, which routes are approved, of course, and you'll see a commercially driven part of it. And then perhaps in some cities, you will have urban air mobility as a public service, perhaps subsidized. I don't have a good city analog, but I can give you a national analog, which is in Norway. So, Norway is long and skinny, and most of the population in Norway lives in the south, but you do have a lot of towns north of Trondheim, small villages where the fjords are located, and there's an airline called Avinor, and they are government subsidized to make sure there's an air bridge to all these small towns in Norway. So I guess some cities could have this kind of analog where urban air mobility would be a complement to public transport, but it would have to be pretty heavily subsidized probably.
So one last question to all our panelists. Among them are some pilots, I know. Would you get on a passenger drone if there was one in 5 years? Yes or no?
I'd like to see the software first.
Okay, thank you very much. Thank you everybody for coming. Thank you for our speakers.